Welcome to Airflight Space. Today, we're investigating a literally seismic shift in Boeing's history. We're talking about a multi-billion-dollar pivot that fundamentally changes how the world's most famous narrow-body jet is built. You know, the 737 has been the absolute backbone of commercial aviation for half a century. But right now, as global demand surges and regulatory oversight tightens up, the way these aircraft come to life is transforming right before our eyes. So you might be wondering, why on earth change a production line that's worked for decades? It's a great question, because for decades, every single Boeing 737 came out of exactly one place, Renton, Washington. Honestly, the Renton facility is practically holy ground in aerospace circles. It is this highly optimized single-purpose machine that at its peak was just pumping out aircraft at a blistering pace. So industry experts naturally started asking, why is this aerospace giant suddenly breaking its own historic manufacturing monopoly? Why fix what, on paper at least, wasn't fundamentally broken? To understand this incredibly complex logistical move, we first got to look at the unprecedented turbulence that forced Boeing to rethink its entire manufacturing strategy. Keep this timeline in mind, because it paints a very clear picture of how we got here. Back in the 2010s, Renton was humming along, assembling an astonishing 53 jets every single month. But then we hit a perfect storm. The 737 MAX groundings, combined with the global COVID-19 pandemic, brought output to an absolute crawl between 2020 and 2022. And even as things started to stabilize, 2023 through 2025 brought these persistent supply chain struggles and strict FAA output caps. This cascade of events created a staggering backlog that Renton, operating under intense microscopic scrutiny, simply couldn't clear on its own. And that brings us to a really historic milestone. According to internal messages, on July 6, 2026, Boeing quietly began assembling its very first 737 MAX on an entirely new production lineup up in Everett. Now, this detail would later prove critical. While the official ribbon-cutting ceremony was slated for July 10, the actual physical work of riveting and routing that first Everett-built narrow-body began without much fanfare 4 days prior. The goal? To prove the whole system worked flawlessly before the cameras even arrived. At first, finding space for a whole new 737 line in Washington state seemed basically impossible. But Boeing executives noticed an enormous opportunity sitting right in their own Everett facility. We're talking about a building famously known as the largest by volume in the entire world. Renton sits about an hour south, right? Meanwhile, Everett suddenly gained this sprawling, empty footprint. By officially ending the iconic 747 Queen of the Skies program and shifting all 787 Dreamliner assembly over to South Carolina, Boeing freed up some prime factory floor space. This allowed them to add that critical 737 capacity without having to build a new factory from scratch, preserving quality by keeping it in a controlled, known environment. If we look at Boeing's internal communications, the mandate was crystal clear. The message read, Boeing teammates began assembling a 737 MAX airplane on the new North Line, replicating the build process used in the Renton factory. The key word there is for sure replicating. The systems installation tool, the sequences, the safety checks, all of it had to be a perfect mirror image of the facility in our South. But as investigators and industry watchers quickly noticed, trying to perfectly clone an assembly line across 2 different cities, that creates a massive logistical hurdle. Okay, before we dive into the specific logistics, we really have to understand the numbers driving this billion-dollar expansion. Here's why this matters. Under strict FAA oversight, Boeing had been capped at just 42 jets a month. As supplier issues finally eased and the FAA lifted those caps, Boeing began a transition phase aiming for 47 jets. But the ultimate goal to remain competitive and satisfy these massive airline backlogs is 52 jets per month. Renton alone just can't reliably sustain 52 under the new, highly rigorous quality control standards. So the Everett North Line is literally the physical key to safely jumping up to that crucial target of 52. Building planes in 2 different places meant Boeing had to invent a way to safely transport enormous, incredibly delicate aerodynamic structures across Washington state. After all, moving a commercial airplane wing isn't exactly like strapping a mattress to the roof of your car, right? Step 1 of this engineering ballet involves the wings being built entirely by the existing experts down at the Renton facility.
Step 2 utilizes something Boeing calls the 737 Wing Transport Tool, which is a specialized system to ferry these critical structures an hour north. Step 3 is the final aircraft assembly in Everett. While Boeing hasn't detailed the exact engineering specifics of this transport tool just yet, this 3-step supply chain is absolutely essential to keeping that Everett line fed. Now, a factory is really only as good as the people inside it. To execute this incredibly complex choreography, Boeing couldn't just rely on brand new hires right off the street. To anchor the new facility, they had to transfer highly experienced talent directly from Renton. Plus, they pulled skilled workers from Moses Lake, Washington, which is a facility where Boeing had previously staged and maintained hundreds of 737s. That means those workers know the airframe inside and out. It's a really deliberate, smart blend of fresh eyes and seasoned veterans.
But hey, even with experienced workers, you don't just flip a switch and start building dozens of planes overnight. Whenever an aerospace company opens a new line, they start with what's called low-rate initial production, or LRIP. Understanding this concept is vital to understanding modern aviation safety. Basically, it is a deliberately reduced manufacturing pace. It allows engineers to closely monitor every single system, catch any growing pains early, and most importantly, demonstrate complete process conformity to regulators before they even think about ramping up the speed. And let me tell you, the regulators are watching closely. The FAA requirement is exceptionally strict. Boeing must prove that Everett's manufacturing processes perfectly match Renton's. If they deviate at all, they simply don't get to operate under their existing 737 production certificate. This became a major lesson for the aviation industry. In fact, Boeing originally planned to open this north line in the second half of 2024, but when the FAA capped 737 output to ensure quality, Boeing deliberately delayed the Everett opening all the way to 2026. They literally sacrificed speed to ensure absolute perfection and satisfy the FAA's strict conformity requirements. As the North Line hums to life, we need to look at exactly what's rolling out of those massive hangar doors. Interestingly, while the Everett facility is technically designed to accommodate all 4 737 MAX variants, their initial strategy is highly targeted. The MAX 8, the MAX 9, and the high-capacity MAX 10 are all slated for Everett production. However, the shortest variant, the MAX 7, is initially excluded from the North Line's production schedule entirely. The reason for this ties directly into the regulatory horizon. Keep in mind both the MAX 7 and the MAX 10 are still awaiting their final type certification from the FAA. Boeing expects to achieve those approvals this year. Once the MAX 10 gets the green light, airlines are going to want those jets immediately. That surge in demand will instantly put this new Everett capacity to the ultimate test, utilizing the massive space to deliver the largest 737s ever built. So what can we actually learn from this story? When we step back and look at this historic multi-billion-dollar shift from Renton to Everett, a very clear picture emerges about the future of commercial aviation and exactly how aircraft will be built for the next 50 years. The North Line proves that surviving in modern aerospace isn't just about designing great jets anymore. It is about relentless, creative logistics. True aerospace resilience requires adapting supply chains like literally trucking wings across a state. It requires exceeding regulatory standards by delaying a factory opening by 2 whole years just to ensure perfection. And it requires reimagining historic logistics to actually build these aircraft under the most intense, unforgiving scrutiny the industry has ever seen. Thanks for checking out this Airflight Space documentary. The way we build the skies is changing faster than ever, driven by sheer necessity and incredibly rigorous oversight. If you enjoyed this investigation, leave a like, subscribe for more aviation investigations and industry stories, and share your thoughts in the comments. Before you go, consider this. If Boeing can successfully clone a 50-year-old assembly line across 2 cities today, what does that mean for the globalized, decentralized aircraft factories of tomorrow? Let us know what you think, and I'll see you on the next flight.